Example of a type 3 projectile. When we solve any projectile, we always set it up the same way. We have our horizontal components and our vertical components, and we treat those two independent of each other. What categorizes a type 3 is it's just that the math gets a little bit more difficult when you're actually finding a solution at the end. But hopefully we'll show you a way to get around some of the more challenging mathematics with this question. Now, first of all, there's been a couple of assumptions just to speed up the process on this one. We're assuming at this stage that finding the two components of your initial velocity are no problem. So remember, this shot was 15 meters per second at 70 degrees to the ground. So this right in here was our original vector, and that angle was 70 degrees, and then we figured out the two components. The initial y value was 14.1 meters per second using sine, and the initial x was 5.1 meters per second using cosine. So that's an assumption we're making right off the bat. I'm not going to show you the work for that. So let's set this up like we always do. We need two directions. So we've got our horizontal, which I always call x, and our vertical, which we always call y, and we're going to merge the two together to see if we can find out our answer. Now the answer we're looking for is what distance to the hoop was required if this shot is good, if it actually makes it in the hoop. So we're looking for this dx down here. What is dx if we want this ball to make it in the hoop? So let's write down our given information. Now remember, horizontally, we've only got the three variables. And Vx never changes. It's always 5.1, tracking from left to right, horizontally. Dx is what we're looking for. Time we don't know, so we can't do much in the x column yet. Now we go to the y. V initial in the y, well, it's on its way up. You can see the red arrow is pointed up. So it's a positive initial of 14.1. I don't know V final. That's the velocity when it reaches the hoop. My acceleration, as usual, is always negative 9.8 meters per second squared due to gravity. And my vertical displacement, if you look at the picture and read the question, is 2 meters. It's going up. It's going from the lower left to the upper right, a vertical distance of 2 meters. So that's a positive displacement because it's up. And we don't know time. So to proceed, if we were trying to find dx, we definitely need to find the time. So normally we look at this column and we go, okay, I want to find time. I don't know V final, so let's avoid equations with V final in it. And sort of the common approach, and this is the solution that's presented in Moodle, is to go like this, to go d is VOT plus 1/2 AT squared, and then stay within this column and plug in all your values. Now, because there's no zeros at all, there's no initial velocity that's zero, there's no displacement that's zero, you've got a term in every spot. There's going to be a value here, and a value here. So you're going to have to use the quadratic formula to solve for t. So whatever's in front of the t squared becomes a in the quadratic formula. Whatever's in front of the t becomes b, and then when I move this over, that becomes c. It's not super hard, but it's quite a few steps. There is a way around using the quadratic formula, and that's to solve for V final in the y first, and then use a different equation to find time. So let's do that. If I want to solve for V final in the y, and I don't know time, here's our equation. V final squared is V initial squared plus twice AD. Now let's go for it. V initial was 14.1 plus 2 times negative 9.8 times positive 2, and I'm trying to find V final. Now when I work all that through on the right-hand side and then take a square root, I'm sure you guys can do that by now, I end up getting V final is 12.6. But here's the key to this. When you find V final, you had to take a square root. And in mathematics, whenever you take a square root, you have two answers, plus or minus. And that's important in this question. We want to decide which V final is appropriate. Well, remember what we did. We found the final velocity when the displacement is 2. If you look at the picture, the displacement is 2 meters at 2 locations. On its way up, it's got a vertical displacement of 2. And since it's on its way up, that would be my positive 12.6 meters per second. On its way down, when it's going through the hoop, that's where my velocity is 12.6 meters per second in the negative. And obviously we want that velocity. So we want to use the negative one because that's the velocity when it's actually going through the hoop. So our final velocity when it's passing through the hoop, we're going to write that down as negative 12.6. If you don't put the negative in, this question does not work. So right here, we're going to say negative 12.6. Now let's choose an equation to find time that's a little bit easier. And again, if we look at our formula sheets, this one makes a little bit more sense. There's no quadratic involved. V final is V initial plus AT. So V final is negative 12.6. V initial was 14.1. My acceleration, negative 9.8. And I want to use this equation to solve for time. So subtract a 14.6 from both sides, divide by 9.8, and I end up getting an equation that looks like this. My time is negative 12.6 minus 14.1. So I subtracted a 14.1 from both sides. And then to get rid of the negative 9.8, I divided both sides by negative 9.8. And when I do that, I get a time of 2.73 seconds. Now, that's the time it takes to get to this point, just before it's passing through the hoop. If I use the positive one, if I use this guy, I would get the time it takes to get to this point. And so if I put a positive in there, and you guys can work this through, you'd get 0.15 seconds, 0.15 seconds to get to that point. So, you have two valid solutions there. You've got to decide which one makes sense for this question. Now, the rest is fairly easy. We need to find dx. So go back to my x column. dx is vx times time. My x velocity is 5.1. And we've decided to use the 2.73 because that's when the ball is actually going through the hoop. And when I do that, I get 13.9, or rounding up, 14 meters is dx.